And I recognize that voice. Okay, guys, I know the jam is not working and all that stuff. And people are down and there's going to be a big walk up to campus. Just hang in there. It's a beautiful day. Okay, come, guys. Okay, shh. All right, we're doing determinants today. So we're just going to do the lecture. Hopefully the recording is good and people can catch up. Be generous to your friends and talk to them about today's lecture because they're going to have missed it, okay? All right? Okay, determinants. Now, determinants, guys, let's focus. Determinants are useful. They are real numbers and not matrices. Okay, so we're going to find something called the determinant today, and we're going to use it to do stuff. For example, we're going to use it to find an inverse, and we're going to use it to solve equations. Okay, that's what we're going to do just today. Okay, so we start with determinants. Determinants. Okay? These are real numbers. Guys, come on. Not matrices. But are you here? All right. But we calculate them. Calculate it. It's a real number, one thing, from matrices. So it comes from the matrix itself. So when we say the determinant of A, it can be written as A with these absolute value signs around it. It is a value, or we can, I'm just giving you notation, determinant A like that. Okay? Now, we're going to start with a simple matrix here. Given A is equal to, I don't know, A11, A12, A21, A22, right? A 2 by 2 matrix. Then the determinant of A is given by, you can write it like this, A11, because remember it's A with the absolute values across it, A11, A12, A21, A22. Now, we're going to calculate it from this. We say this times this minus this times this. All right? So it's the left diagonal. You multiply the left diagonal and you subtract the right diagonal. All right? So that way is positive and going down that way is negative. All right? So it's equal to A11, A22 minus A12, A21. And that will result in a scalar, right? A number. Okay. All right, so quickly do a nice simple one. Find the determinant of A, where A is, I don't know. Let's see. 1, 2, 3, 4. All right? Have you done it? Have you done it? The left diagonal minus, yes. All right? So it's your left diagonal, 1 times 4 minus 2 times 3. So it's 4 minus 6 is minus 2. So we write determinant A is equal to that. All right? So this is the value here. Okay? So you know how to find the determinant now. So now we're going to, yes, question? No, it doesn't mean, it's just a notation that it looks like. It doesn't mean we're taking the absolute value of it. It's not like we're finding a length of something. We're not finding a magnitude of it. It's just a notation. I know maths is one of those funny ones where you've got, use limit twice in 2 different contexts, right? Limit as something approaches it, and when we talk about integration, the upper and the lower limit. So sometimes it's got more words, more meanings to the word, right? For one single word. So here, this absolute sign doesn't mean the actual length of it. It just means it's a determinant, something useful that we find to do stuff with. Okay? Question? All right? You okay? All right. So now we're going to use this thing. Okay, so it's easy to find the determinant, okay? We'll do a determinant of a 3 by 3 matrix a little later. For now, let's just use it, okay? Determinant used in finding, yesterday we did inverses, so now we're going to find the inverse without Gauss reduction. Okay? All right. Unless you want to do Gauss reduction all the time. Nah, I'm joking. It's nice. Gauss reduction is nice. If A is equal to A, I don't know, B, C, and D, right? Then our determinant of A is equal to AD minus BC. Yes? Then what we say, then the inverse is equal to 1 over the determinant of A times, now watch what I do now. I'm going to swap the left diagonal entries, right? So then what must be here? D. Yes? And this side must be A. Oh, A. Right? So we swap the left diagonal entries and put a minus in front of the right diagonal. And put negative signs, or multiply by negative, put minus sign in front of the right diagonal. All right? So now we found the inverse. Are we actually certain that it's the inverse? Okay? So it's 1 over AD minus BC times the matrix D minus B minus C and A. So that's what we're saying is our inverse. Right? Can I prove it? Can I show? Let's use the conventional way. Right? I'm going to Gauss reduce. Right? Yesterday we did inverses, and when we find it losing the long method, what do? We put it into an augmented matrix, a matrix A, right? With identity on the left, and you Gauss reduce until you get the identity on the left and your inverse on the right. Isn't that so? Is that so? Yes. Okay. So quickly do this, the long method. A, B, C, D, and 1, 0, 0, 1. Come quickly, Gauss reduce. For fun. For fun. For fun. Maths is fun. For fun. It's not fun. No, no. Grumpy, grumpy, grumpy. All right. Shh. Okay, I'm going to help you out. All right. I'm going to leave the first row as is because I'm feeling lazy. And then I'm going to say, what's so exciting? Okay, we're going to say row 2, A times row 2 minus C times row 1. So that will become a 0 there. A times row 2 minus C times row 1. That disappears. A times row 2 minus C times row 1. Oh, AD minus BC. Look, look, look. And then A minus row 2 minus C. Is it minus C times row 1? And A is there. A minus, okay? And then the next step, we want to make that a 1, we divide by. No, actually, we want to make this a 0. And what can we do? We can say AD minus BC times row 1 minus B times row 2. That will give us 0 there. So we've got A times AD minus BC minus B times row 2. And this one, that becomes 0. Right? And that becomes AD minus BC. Hang on, AD minus BC minus CB. Is it going to be plus CB? So those two cancel. Yes? Oh, lovely. And then 0 times row 1, that times 0 minus AB. Is that correct? Yes, that's correct. It's not that bad, guys. Come on. AD minus BC. And on this side, I'm going to divide by AD minus BC now. That becomes 1. So this is minus C over AD minus BC. And that's just A over AD minus BC. Woo. What's happening? Hey, I thought this. Hey, but why did he run out like that? Okay, shh. Guys, sorry about the disturbance. I got distracted. Shh. So now, are you happy? I'm going to divide the top row now by AD minus BC. Shh, come on, guys, let's go. This is checking the conventional way. This is shocking because he left his bags and just ran. Okay, so then the left-hand side, if I divide by, on the top row by A times AD minus AC, we get D over AD minus BC. And we're dividing by that, and we get minus B over AD minus BC. So we've divided row 1 by A times AD minus BC. Okay? All right. And what's that? Minus C and A over AD minus BC over AD minus BC. And so it's very obvious your inverse is what we found earlier. If I take out the scalar, guys, clearing throats. D minus B minus C and A. All right, so we can show it. I'm going to give you more proof-like questions in the... Okay. All right, quickly do now, because we have to just check we've understood the concept. Find example there. Quickly now, find the inverse if A is 1, 2, 3, 4. Quickly. Are you done? I'm joking. Come on, quick. Are you going to take out your books? Hey? Now you found the determinant. Now you are finding the inverse. Okay? Earlier you found the determinant. Now you're finding the inverse. You use the determinant. So, it's 1 over the determinant of A times the matrix, that is, you swap the left diagonal and put the minus in front of the right diagonal. And that's it. You writing it down, guys, is no hard work. Isn't it nice? Yeah. Okay, so your inverse is 1 over, your determinant is 4 minus 6 is minus 2. So it's minus a half times, I'm going to swap the left diagonal, 4 and 1, and put minus in front of the right diagonal. Are you okay? Where's Ati? Is he all right? All right? Okay. Have you got it? Yes? No? 3 bags full? No? All right. Shame. It's very strange talking to half the class. Very strange. All right. Shall we do something more? Yes, we've got it, so it's easy, right? Easy. I love it. It's easy. Matrices is easy, guys. It's nice fun. It's fun. Okay, now we start Kramer's rule. Are you ready for this? Okay, if you've just arrived, settle down, sit down. Question. You can if you want to. You don't have to. Remember, a matrix, if they ask you for a matrix and you leave the scalar out, that's fine. That is 100%. It's like saying you can leave it like that. It's fine. It's the answer. So here we have inverse. If we had written it like, what is it? If I multiply, so that's minus 2, 1, what's that? 3 over 2, and minus a half. If I wrote it like that, that's also fine. Okay? We don't have to multiply it in. When you've got the scalar and the answer is the same. Right? Okay? Question? Right? Determinant with the inverse. Okay, shh. Did you just arrive? No. Okay, guys, one more time. Guys, I'm slowing down and I want this whole thing recorded. And I actually want to go on to Kramer's rule. So one more time, a quick squiz to find the inverse using the determinants. What do? You say the scalar that's outside the bracket is 1 over determinant of A, right? And that determinant is your left diagonal minus your right diagonal. So it's going to be 4 minus 6, right? I'm multiplying the entries. 4 minus 6. So that's why I got 1 over minus 2. All right? So it's 1 over the determinant of A times I swap the left diagonal entries. So it's 4 and 1, right? These swapped. And I put negative signs in front of this. Okay? So if this was minus 2, it becomes plus 2. But now it's 2, so this becomes minus 2, and that becomes minus 3. Okay? So it's swap the left diagonal, put negative signs in front of the right diagonal. Okay? Nice way to remember it. Okay? All right, so now Kramer's rule. Kramer's rule. Now, Kramer's rule is used to solve a system of linear equation. Okay? We'll start with the 2 by 2. There's plenty of practice with the 3 by 3 later on. Once we've done, I'll show you how to find the 3 by 3 determinant. So here your determinant is used in solving a system of linear equations. All right? So I've got the system of linear equations. Ax plus by is equal to E, and Cx plus dy is equal to F. That's my system of linear equations. We could write it as matrices A, B, C, D, and that's going to be X and Y, and the answer is going to be E and F. That's easier to see, right? Right? No. Are you practicing what I asked you yesterday? 3.1, 3.4, 4.1, and 5.1, hey? From your printed notes. If you don't have the printed notes, if you were missing last week sometime, please come and get them from my office. That's all. Come and get it. Then I can blast you. Okay. All right. Shh. Now, if we could Gauss reduce this and solve it, right? But we're not. Okay? So using Kramer's rule, we say that, watch this, your x, it's simply x is equal to and y is equal to your determinant of your matrix. Let's say this is A, this is your x vector, and this is your B. Right? So we're solving for x. All right? So we're solving this coordinate x and y. So we take on the denominator is the determinant of A, B, C, D. All right? And the determinant of the numerator is I replace the x column. Watch this. I'm replacing the x column by the B column. So what I get E and F here, and B and D. All right? Let me write it down somewhere. So put a star there. We replaced the first column representing the x values by the b column vector, right? That's what we did, all right? And in your y, we replace on the numerator, we replace the second column by the b vector. Let me use a different color. All right, so we replaced the second column, which represents the y values, by the b vector entries. Okay? So this is E and F. This remains A and C. All right? And then the denominator stays the same, A, B, C, D. Right? So then what is X? What is the determinant of the top one of the numerator, I should say? ED minus BF. ED minus BF over AD minus BC. AD minus BC. Okay? All right? That will leave you with a number. And we've solved I will do some actual number crunching just now. Values. And then this one will be AF minus EC. Right? And AD divided by AD minus BC. So here we get our solution. Okay? So when we are solving the set of linear equations, when we are solving this and we are told to use Kramer's rule. So now, look, we're just doing the easy ones now, but look, we can solve a system of linear equations so many ways. We can simultaneously solve, right? We can Gauss reduce, right? Here we are finding the determinant and using Kramer's rule. It's nice, eh? Or you could use a system of matrices and multiply by the inverse if we knew the inverse. So many ways to solve a system of linear equations. Okay? All right. So then solve, example, solve 2x plus 3y equal to 5 and x minus 2y equal to minus 1. And it's telling you using Kramer's rule. Shucks, it's raining. All right. So, can you attempt it? I think it's straightforward. This stuff, it's just too yummy. Or we could write it out as a Gauss. 2, 1, 3, minus 2, 5, and minus 1. If you do it in your head, that's fine. Just be careful, hey? So here we got, guys, it's going to be minus 10 plus 3, which becomes minus 7. And this is minus 4 minus 3 is minus 7. So our answer is 1. X is equal to 1. And here we've got y is equal to, I'll write it here on the side. That is minus 2 minus 5 minus 7 minus, we know that already is minus 7, and so that's also equal to 1. And it's such a nice, easy one. They're not always, hey, no, they won't always equal to 1. This is just a nice, very fruitful example. So we can write our solution as, we're finding the solution of it, we can write it as a column vector. So xy is equal to 1, 1. All right. Okay. Just got a few more minutes left. So then we can do the last thing we can do is find the determinant of a 3 by 3 matrix. And so then Cramer's rule for a 3 by 3, you'd use the same idea, all right? Once you find the determinant, okay, so then it's determinant, so x, y, and then z. Right? You're replacing the corresponding columns.
Yes, what if they meet at the line? Would you find a point where they meet, or if they...
Okay. There's a very useful question. Guys, what happens if we've got a 3 by 3 matrix and our solution happens to be either no solution or infinitely many solutions? It means my determinant, when I find it, is actually equal to 0. Okay? Once we find that the determinant is actually equal to 0, it means that actually you can't find the inverse. And yeah, it's just, there's lots of, we can't solve that using this method. Okay? Okay. Velani asked, so what happens when when there's a infinitely many solution, right? Or the system of equations has no solution. You end up with the determinant being equal to 0. Then I cannot divide. I can't say 1 over, yeah? So you cannot find the inverse. And the same way is that we cannot divide by this determinant, because then this would be 0. All right? So you cannot use Cramer's rule to find the solution then. All right? Okay. Whew. So once you find that the determinant is 0, then quickly graph reduce. All right, determinant of a 3 by 3 matrix. And you notice that we can only use square matrices, eh? Yes? Okay. Okay, given A, oh, I'm going to do it the long way. Given A is equal to your favorite A11, A12, A13. Come, guys. Just write it out because you know what's coming next. A21, A22, A23. A31, A32, A33. Right? We've got this with unknown coefficients or known coefficients, but we're doing the general thing. Then the determinant of A can be found I'm going to show you two ways, and then you can decide which one works for you. So method one, I can say is, method one, let's see. You can write out it, and you know how when we do it, how we do the cross product in vectors, we repeat the last two columns. So we can write it out like that. So A11, A12, A13, A11, A12. You write out just like how you would do the vectors when you're crossing vectors. You're repeating the first two columns. And A31, A32, A33, A31, A32. All right? So method one is write out the entries with repeating the first two columns again. Does that make sense, eh? You write out the entries, then you repeat the first two columns again. So then, watch this. The left diagonal, you multiply the left diagonal, right? And you say plus. All the left diagonals is plus, and all the right diagonals is minus. So it becomes A11, A22, A33 plus A12, A23, what's the next one? A31 plus, so it's all the left diagonals. You're multiplying the entries and you're adding them. So left diagonals you add. It's usually the convention. A13, A21, and A32. Okay? Then you subtract the right diagonals. Minus your right diagonals. Let me get a white chalk. So it's this one, and this one. So you basically, you don't want to remember these things. You want to remember the way you did it, the method. I multiply the entries of the left diagonal, and I add it to the other two. And I subtract the entries of the right diagonals, right? When when they have been multiplied already. Okay, so it's A13, A22, A31 minus A11, A23, and A32. And the other one is minus, gosh, I'm running out of board space here. A12, A21, and A32. Okay? All right, so it's your left. Let me go over that one more time. It's your left diagonal. You multiply the entries of the left diagonal. You add them to the next one and the next one. So 3 diagonals. You multiply the entries and you add them. Then from the right diagonals, you multiply the entries and you subtract them. Okay? It's that simple. That's method one. The other method, right? So we in effect we end up with a number. Yes? No? So all these values, we end up with a number equals to something, a real number. Okay? Because we know our determinant is a real number. All right. The second method, maybe it's easier. Or we can calculate it this way. What you do is you take your first entry, right? So it's A11, and you write out, so then you block, using your hands, you block out these two, and the remaining 4 becomes your matrix. What's wrong? Time out.
No, he's excited.
Oh, you're doing it. I thought you were giving me a timeout.
No.
I'm a naughty child. Timeout means 2 different things. All right. Sorry, distraction. Hey. Come sit down if you're going to sit down. Don't chat. All right. So see what I did. You take the first one and you multiply it by the determinant of what's remaining in that. So you block out the first row and first column, and we get A22, right? And A23, A32, and A33. Okay? Watch this. Now it's a minus. All right? It's always a plus, minus, and a plus. Minus this one, right? Your second column entry in your first row is A12. Again, you block out the one with it, okay? So the first row and the second column. Okay, you're blocking out that. Like that. Okay? And what do we get? Come on, read it out to me. A21, A23, A31, and A33. And then you add A13, the last row, the last column, first row entry. And that times blocking this one out. That. All right? So it's A, blah, blah, 21, A22, A31, A32. You end up with the same number. All right? So this times that minus that times A11. Actually, if we take A11, these two numbers, you'd get those. Yeah? The middle one, did I write it wrong? So, guys, shh. So the middle one you have to put a negative in front of it, right? People often forget this negative sign. This must be negative. Must be negative. All right? So it's a negative times that value, right? You hide this, and you've got A21, A23, A31, and A33. Have I written it right? A21, A23, A31, and I did.
No, but you said you're blocking out the column with A13.
A12. That's for the middle one.
Oh, you should do the middle one.
Yeah. Okay?